back from. I was camping for 4 days.
Oh, nice, dude. Camping is the best.
Yeah, I needed it, man. It was good to
That's
get
what's
out.
up. That's what's up.
Yo, what up, Fatal?
What up, Fatal? The main scene, my monitor, and all this. Very cool.
Oh, you know what? This has not been live.
Oh shoot.
I was live streaming an empty Discord. There we go. Now we're live.
Discord stream kit or whatever. 1 second. Need to get my overlay for the audio channel.
Welcome to the fourth Aether Roundtable.
You're echoing super hard.
There, that should be fixed.
Show speaker user only. Hide names. Yeah, show speaker. Yeah, there we go. Testing 1, 2. All right, cool. There we go. All right. Then let me link the old live stream, and then I'll start my presenting. All right, cool. There we go. All right, Melodome, Jaren, Ghostbusters. All right, cool. So let me see here. Screen turn on camera. There we go. Do you see that? Or do you have it on your thing to display for YouTube, Toby?
Yeah, I will. Right now it's just like an empty OBS thing.
Oh, you know what? I gotta start my virtual webcam. That probably would help, right? How's it now?
There we go.
Fantastic. All right. So here we have for ether wind and ether experiments for the history of interferometry. We're going to go over a couple of new experiments that I found out about recently that I've been studying that show some really insane results in regarding to the Sagnac effect and making modifications to the Sagnac device and doing different tests in that regard to see what exactly is the cause of the Sagnac effect and what can they learn from it. So we'll take a look at their paper here and go through their publishings. We'll read a little bit of their what they have to say, and go go from there. So this is Dufour and Prunier, 1942, abstract. In the first of these series of experiments described herein, we use an optical circuit entirely fixed to a rotating platform, as in the previous work of Sagnac. Under these conditions, we found that the movement of the fringes observed is similar within 6%, whether the light source or the photographic receiver is dragged in the rotation with the frame, with the platform, as in the Sagnac experiment, or when it remains fixed to the laboratory. So we'll get into the distinctions there that they make, and how they achieved such a setup, right? So we'll go through the original Sagnac setup here, where everything is on the inertial frame. And a quick thing to note rather is some relativists will say that a rotating device, that the Sagnac device in particular, is a non-inertial frame, so relativity doesn't apply, doesn't falsify it, and all that stuff. Well, Einstein's definition of an inertial frame is if his equations hold true in an inertial frame where it's at rest, if a frame is in uniform rotation, right? But then that can also be, then his equations should also hold valid in all frames, in regards to that rotating disk. Now, what the relativists can do is they can derive the effects from the from the center of the platform. But as we go through the experiments, we're going to see that the first postulate of special relativity about all reference frames being equally valid isn't true. So we'll get into that. Shane might be coming on here in a second. Oh, you're echoing out, Toby. The craziest echo. All right. Okay. Yeah. So this is their second configuration of the setup here. So what they did is they took their light source off of the inertial frame. I don't even like calling it a non-inertial frame now that I've read Einstein's direct quotes and thoughts on what constitutes an inertial frame and what doesn't. So giving them the vernacular of this not being an inertial frame when it's rotating uniformly, they take the light source off. They place it on the lab wall, and it's shooting a beam here. There's a collimator where it focuses the light beam, and then there's a before it hits the platform, and then there's a collimator on the platform where it reamplifies it, keeps it nice and tight, and then it hits its reflective mirrors, yada yada, and then goes in here at P, that's where your observer's at, and the observer determines what type of frame it is. So where the observer is locating it, if they're stationary or if they're in uniform angular acceleration or angular rotation, that's an inertial frame, right? So our inertial observer is going to be here, and our light source is going to be here. And the purpose of this is to determine whether or not the effect is caused if the source is rotating with the device or not, right?
Go, Alan.
What's up? What's up, Toby? One second, we're sorting out some technical difficulties, I think. Let me know when I'm good to go. All right. I'm not sure what's going on. I'm just going to go ahead and continue. So yeah, the purpose there was to test to see what causes it, right? If the light source is connected or not, if it's rotating or stationary, right? So what they found here is that the fringe shift produced matches as if it were attached to the device. So there's a variance shown irrespective of the location of the source, right? So the second postulate holds true in that regard of Einstein's special theory, saying that the speed of light is independent of the motion of the a source or observer, right? So far, from as it pertains to the source, we're good to go. It's looking good for special relativity so far. Now here they get into their third configuration, where they have the source and the photographic recorder fixed to the laboratory, and they got the rotating device. And I'll show you the setup here, how they did this. It's really cool. So they got the source here fixed to the lab, and it shoots its beam in their collimator here, to refocus the beam. Hits a stationary platform on top of here that's configured with 45-degree angled mirrors that reflect it down to a rotating platform that have angled 45-degree mirrors as well. So it hits all this. It recombines here. There is an observer attached or a recorder attached here as well to take a reading. So we have a reading on the rotating device as well, and we have a stationary observer as well here. So it hits this, goes through here, recombines, hits everything, takes a reading here, and then there will be a reading here. Now the iteration that I just described there, where they have both setups going, that's an experiment that they did after this configuration, but they go into detail through the text here. But this is the way that I just laid it out is the final iteration of what they did, which is crazy for the comparisons, right? So here's a little graphic to kind of showcase what they did. So the height difference between these two mirrors, like it looks like a crazy discrepancy here. It was 4 inches. So 4 inches stationary platform here, doesn't move. an independently rotating platform underneath it, separated by 4 inches, and then fixed to the wall here behind it. Obviously stationary, non-rotating, is the source of light in the photographic recorder. Here's a topographical view of what that kind of looked like, with C being the center point of the axis of rotation for the device. So this C right here just goes up. That's the axis. It's the middle, cutting through both discs or platforms. All right, and then so the results are as follows. Oh no way! They matched the they matched the Sagnac's original configuration. So that's cool, man. So what happened there is in the relativistic paradigm, a so-called non-inertial frame transferred a variance in speed of light to an inertial observer, which absolutely cannot happen. It's a complete falsification of relativity. And it also let's see, what's the word I'm looking for? It validates Sagnac's original interpretation of the ether wind with his experiment. So obviously, knowing that Einstein's view on inertial frames and all that, we'll look at how Sagnac described it. Where's my Sagnac quote about the atmosphere?
Yo, can you hear me?
Yes.
All right. So sorry about that. All the weird audio issues. So yeah, I think we missed like the first 5 to 7 minutes of audio or so, or I'm not sure exactly how long, but
Ooh.
it was. But yeah, my stream was messed up. I didn't have audio going out.
Dang.
It's fixed now, but yeah, unfortunately, I missed when you first kind of introduced the subject.
Well,
matter.
I just realized I might not even be live either. So give me 1 second. I might have just did that all fucking for nothing.
Yeah, I didn't have audio.
Oh no, I'm live. I'm good.
And then I've only been able to pay half attention because I've been trying to fix the audio stuff while I'm trying to listen.
Dang.
Yeah,
I'm good. Yeah, that sucks.
Cool.
Okay.
Good. Wait, so you are at least recording or
yeah, it's fully good on my side. So yeah, I can kind of recap here. So what we missed. So I was going over this Dufour and Prunier experiment. Did you hear any of that part?
Yes, a little bit, yeah.
Okay, yeah. So these guys, they took the original Sagnac configuration and they reproduced Sagnac's work. And I think that's an important distinction too, the way that they did their experiment, because in modern renditions of Michelson-Morley experiments, so-called, they don't use a device analogous to how Michelson had it set up, and they don't follow the way that Miller did it. To try and reproduce these things. But the way that they change the apparatus completely, affects everything. So the first step that they did, I think, really showcases the integrity that these guys had for their experimentation, because they reproduced the Sagnac in its original configuration. The only modification that they made, they actually were able to use some of the same parts, but the only modification that they made is that the diameter of the disc is 2 times bigger than Sagnac's original configuration. That's the only thing that they changed. They just made the disc bigger.
Interesting.
Yeah, so it's really cool that they were like, okay, well, Sagnac said he did this, but let's see if we can reproduce it, because that was in 1913 with Sagnac. So this is 1942. So they were like, let's see what's going on here with this rotating disc situation, and they reproduced a fringe that corresponds to the rotation of the device at 1 turn per second, which is a very important distinction, right? So all these measurements that they take are going to have a first order dependency on the rotation of the platform, and the platform rotates at 1 turn per second. So with the first Sagnac experiment they did, all the instruments are located on the rotating device, and then they got their fringe pattern that corresponded to the prediction as laid out by Sagnac, right? Which produced a fringe of what was it? It was it shows in the pictures here as I scroll down. We'll get to it. But anyway, they did another configuration here where they have the light source fixed to the lab wall, and they use 2 collimators to keep the beam in focus as it transfers from the stationary to the rotating platform. And then it completes its circuit within the rotating device, and it ends up here in P, which is the photographic recorder. And that's where it's going to get its, take the fringe displacements. And what determines what a reference frame is it an inertial, non-inertial, etc. All that is determined by the observer. So the observer here is located on what's relativists call this a non-inertial reference frame, but Einstein defines a uniformly rotating platform as an inertial frame. And states that any situation where his linear equations hold true, so should it for a rotational, as long as it's in uniform rotation, it's not deviating, accelerating, that kind of stuff, right? So some relativists will argue that because it's rotating, it's a non-inertial frame, blah blah blah, but it's not true. Using relativistic math, they can take the reference frame of the center of the rotating disk and extrapolate outward from there. But what they can't do, what they found, is that they can't do it from another location on the disk, and we'll get into that configuration or that experimental configuration towards the end here. But yeah, so the important thing to note here is that for like 8 years, the Sagnac effect went unanswered by special relativity and general relativity, and it wasn't until Paul Lavue stepped in with general relativity to basically say that the energy of the rotation of the device creates little pockets of length contraction and time dilation. And that's just, of course, expressed through abstract mathematics. It has no physical substance to it as an actual meaningful mechanism for anything. It's just an abstract kinematic description. So that's all they offer for that, and they can only do it from a specific reference point. And in special relativity, the first two postulates are adherence to Lorentz symmetry, meaning that all inertial frames are equally valid, and that's expressed through the mathematics. So any point on any not just using the center here, relativity says that it should be able to derive the correct displacement from any location on here because all inertial frames are equally valid. So if they were going to do that through the mathematics, that's how they would test that hypothesis, rather, right? Mathematically, and then the second postulate being that the speed of light is independent of the motion of the source or observer, right? So keeping all that in mind, and how Einstein describes or defines an inertial frame, and how he defines a rotating frame when it's in a uniform motion, it should be absolutely equivalent to someone who's stationary. Okay. So any questions so far?
Can you explain the diagram one more time?
Yeah. So for this diagram, this is the second configuration of their setup, where they have the light source here. This is your S. It's shooting a beam into this collimator here right before it doesn't. This collimator isn't attached to the platform. It's just refocusing the beam into another collimator that's on the rotating platform. And when those focused beams get aligned, it hits this split mirror, hits this, and then it completes its rotational path back to here, and then it hits your boy the photographic recorder that's on the rotating device. So it's like the device is rotating, and it has like a split second, so to speak, but it's light, so it's really fast. It has enough time to complete a circuit like 17 times or something in the time it takes for that one pass for them to line up, right? So more than enough time to get the reading. But that's kind of what they got going on. Does that kind of make sense now?
So when you say that it should be like you talk about the reference frame, you would, because that's a point within the circle that's spinning, it should be within the same reference frame, correct?
Yes. Yeah. The observer, with the observer's location determines if it's an inertial reference frame or not. So like the source being here doesn't determine anything about the reference frame itself, because this isn't even attached to the rotating device. So the distinction there is that the observer is what determines the reference frame, if it's inertial or not. What's happening to the observer?
In this case, being the recorder.
Yes. Yeah. So yeah. The recorder would be substituted as observer.
Cool. Okay. Thank you.
Yep. And then a couple other distinctions here too. So a reference frame implies an observer, like an actual physical thing that you would be able to make like dynamic predictions with, right? And then a coordinate system would be like an abstract kinematic situation. And the way that the lingo is facilitated in relativity and mainstream physics and all that, the distinction is super blurred. I was reading this interesting paper about that subject from Robert Bennett, who goes into detail, because you know how we say, like, from our outside perspective, we make the broad claim that physics and stuff is compartmentalized, right? And they laugh at us. They're like, "Haha, you're fucking stupid. You think we're compartmentalized?" Well, yeah, like this is the compartmentalization right here. The blurring of the lines between a frame that implies an observer that has like practicality that must be, true, and a hypothetical coordinate system that's useful for analytical purposes and things like that. So really,
Yeah.
really, really interesting distinction there. And then what relativity or what irregardless of however Einstein phrased it in the beginning, what's been put forward now is that these kinematic frames, these analysis frames, these hypothetical frames are all valid in real frames, right? So that's kind of what they've done there. So when they say that the Sagnac device that how Einstein defined it as being able to fully incorporate any of the effects as long as it's an inertial frame, as long as the stationary calculations hold true, or for an inertial frame or observer, sorry, that it should be good to go. But what we're going to find out is that when you force them to not use a preferred frame, right, this center location, stationary, non-rotating, relativity fails miserably through further experimentation. So
Interesting.
yeah. And then so these are the fringe patterns. This is from the this is from the original configuration here. This is showing the fringe displacement. And then this is from the second configuration where the light source is fixed to the lab. So this is showing that clearly the inertial motion of the system is responsible for the fringe pattern, and it doesn't matter if the light source is moving or not. It's all determined on the observer so far. This is what they've experimentally deduced from this so far, is that the inertiality, right, the velocity of the system or whatever, is what is showing the effect. Not, it doesn't matter if the source is rotating as well. Sorry about that. There's some background noise at my house. Okay, so for their third configuration, what they did is they have a light source fixed to the lab. They got their collimator here. They have a disc above that's stationary. They have a mirror here that splits off, beam splitter, and recombines. But when it splits off here, it hits a 45-degree angled mirror, hits another 45er, and then down here is your rotating frame, right? And then in the final configuration of this, they actually attach an observer here to take a recording based off of this recombining and splitting mirror here, and then they still have the
observer.
They have one here that's on the rotating device, and then they also have one that's on the lab wall, because this, like how it reflects back and recombines, they have a dual setup. So what we're going to see here is they're going to try and isolate the effect of the inertial system, its motion, and see how this affects for an Einstein defined inertial observer that's actually stationary, versus an observer that's inertial and rotating with the system, uniform rotation, stationary observer, all that shit, right? So basically these two frames should be equivalent, right? Right. So we're going to see what happens.
Yeah.
So we're going to see what happens, right? Now, in relativity theory, the fixed lab observer should see no fringe, right? The spinning situation down here, recombining up here, because it should not be, they should observe no fringe. And then the stationary, and then the recorder attached to the device should see a fringe. It should still see it because it's with its inertial, it's moving, right? But because they're not actually connected physically, the stationary lab should see no fringe, right? So here's the overall topographical view of what it looks like, and I kind of color coded the mirrors and stuff like that, or whatever, so you can kind of see what's going on.
I have a quick question.
No, you're good.
The fringe is based off of. Is it two separate fringe patterns that they're looking at then, right?
Yeah, they're going to compare.
Okay.
They're going to compare two readings.
They're not recombining these two separate signals to get a fringe there. It's literally two separate fringe patterns.
Yep, they're taking two separate readings and comparing. Yep. And then so one more time, topographical view of it. Your C here is your axis of rotation between the two. disk, and then this top part here is your stationary disk that reflects back to the lab wall where the observer and source are stationary. And then this green section here is your rotating all that, and this should be green as well right here. But yeah, so this is where your where the observer attached to the rotating platform was located, right? So what they did here, so here's a picture of what it looks like. It's not very good, but the distance here between those two platforms is only 4 inches. So we have the rotating platform is on the bottom, and we have the stationary platform on the top, and then fixed to the lab behind it as the source and an observer. And then there's a recorder here somewhere. Oh, I think this might be it right here. That's on the edge here of the rim where they take their other measurement on the rotating device. All right. So what they found here, this is a topographical view of the path of light that it will take. All right, between the two disks, and this is the fringe shift patterns that they got. So for the lab guy, or for the observer fixed to the lab, they got a fringe that fully matches the rotation of one rotation per second, and for the guy on the device, they got the same reading. Or for the guy fixed to the rotating frame, first order dependence on rotation, right? So that's pretty crazy, right? So this rotating system that's not attached. This rotating system at the bottom here that's not attached to the wall is changing the speed of light for the observer, right? So how Sagnac thought of the ether wind, right? His the way that he geometrically described it was that there was a uniform atmosphere, right, of ether wind, right? Because he was a globe lad, right? So he imagined that we were surrounded with an atmosphere that rotates with the globe of ether, right? And within that ether field, if you're rotating on the surface of the Earth, you generate your own ether wind within that greater vortex, right? So the way that he describes the analogy here, I'll read it off. In a moving system as the whole, relative to the ether, the propagation time between any 2 points in the system should change in a way similar to a stationary system subjected to an ether wind. The relative speed at which point of the system will be the same as directly opposite to the speed of any point, and would contain light waves in a manner similar to atmospheric wind carrying sound waves. So it's getting that propagation speed boost, and it's catching a delay, right? So going upstream and downstream kind of way, because it's all flowing in one direction, right? East to west. The greater ether vortex, right? So the observational of optical effects of such an ether wind relative to a stationary ether will constitute a proof of the ether's existence. So what he's talking about is that counter propagating ether wind from a rotating, within the atmosphere, the greater atmosphere, right? So just as the observations of the wind relative to the atmosphere on the speed of sound on a moving system would constitute everything else being equal as proof of existence of a stationary atmosphere enveloping the moving system, right? So absolute body bag, because Sagnac read the full electrodynamics on moving bodies paper. He was, he knew that how Einstein defined an inertial system, and that's an inertial frame, and that's why he made that claim, right? Because the Sagnac effect fully applies to it. And I mean, look at the logic with what he showed and what he measured. So what he measured is that the speed of light when it's recorded has a first order dependence on the rotation of the device. So it varies, fluctuating based on how much rotation there is. It's proportional to that, directly to the first order. It's insane. And the only thing that would facilitate such a mechanism would be the ether, because in regards to how they used to say, like, what's an absolute reference frame, and what's it relative to, and there's no absolute motion, because there would have to be the implication would be that it's with respect to an absolute frame that you would compare it to. All these things that relativity denies is the mechanism that facilitates that variance to the first order degree.
Can you drop that paper in the chat?
Yeah, absolutely. 1 second. So it is Dufour and Prunier, 1942.
This is just more
Yeah, this
amazing
is
stuff.
this is great. And then my boy Robert Bennett, who's going to be joining Witsit on In the Field soon, hopefully, is going to do a 2-part presentation on all of this, like philosophy and science, and like the basis of, or like why it's important to have both, for to have a framework of interpretation before you even get to the crazy shit like relativity and all that. And then on the second part of it, he's going to break down all these experiments, Wang, Aries failure, Michelson-Morley, Michelson-Gale-Pearson, like all these that are on this list, Dayton Miller, Yuri Galev, Monera, dude, he's going through the whole gambit. It's going to be awesome. So definitely check that out when it comes to fruition. But yeah, so this guy's paper right here, he points out a lot of this and shows and stresses the importance of the kinematic and dynamic relationship in mathematics, and how one is used to, analyze motion and not necessarily describe the mechanics behind it, or like provide an underlying mechanism, right? Because take a look at the framework for special relativity. There's no mechanism. They literally can track the coordinate system to to their measuring stick, to the speed of light. So like it's crazy. Yeah. All right. And then, oh yeah, Robert Bennett right here. So Dufour and Prunier. So there's their analysis, and then I'll drop the papers here in 1 second.
Yeah, just denial of just making up your own interpretation of all the other constants in order to deny them and only accept speed of light constant. I mean, it's
nuts. It's nuts, dude. The only frame that we can do things in, the only frame that's in dynamics that's actually covariant is the lab frame. So the stationary non-rotating frame is the only frame that we test things in, or that we can test things in, and it's only explicitly showed that there's a variance in the speed of light proportional to the rotation of the system. And it's like, oh, I wonder, and then so we've only ever seen a variance in the speed of light, and we're like, oh, you know what that means? That the speed of light's the same. In reality, is changing in the direction of motion to make it seem like the speed of light's changing. Yeah, dog. Like, and then David Blaine like comes down from the stadium or whatever, and he's like, I did it. Or
right.
Like it's like, what are you talking about? Yeah, so 1942, let me get the Dufour and Prunier.
That's such a good analogy.
It's such a convenient conflation.
Yeah, and it's like, in kinematics has a place in like the abstract mathematics and stuff like that. Like you can analyze motion of a system, make predictions off of it, and then apply dynamics to it, and then see if the predictions hold true, and then you start forming laws of motion. Right? So like all the like they call it what they used for dynamics and analysis, the mathematics that they use a, what do they call it? A Lagrangian something. But anyway, it just like analyzes it. It's like real, like it's calculating the real forces and all that kind of stuff to make the predictions and see if your predictions hold true based on your kinematic stuff. And then from there, you recompare, and then you're either experimentally verified or falsified, right? But like they just never apply that dynamic situation to relativity, because everything in the sky is abstract, right? Like as long as they convince enough people that the stuff in the sky, holds true for relativity, the effects that they measure down here with the variance, they're like, oh yeah, of course it changes, gravitational field, potential, and all that stuff. It's like, that's why you see these experiments like Heffel-Keating, Pound-Repka, Pound-Snyder, and all these things that are like supposed to be supplementary to the gravitational field effects that support relativity theory. That's why when you read the papers of them and you like in it, they don't prove anything about the so-called relativistic effects, these kinematic effects that are used in the abstract mathematics of relativity theory to describe motion. Right.
Right.
They're hollow, and that's why
Lagrange points. I just put a Google search on that because I know that it's like parking spots in space.
So Lagrange was a mathematician / physicist, but according to sources, he was more of a mathematician. But yeah, he came up with a way to analyze the motion of a system I forget what it's called. I have to pull up Bennett's stuff on it. Let me see if I have the notes available real quick. That would be pretty clutch if I did. Oh, I do. Okay. Cool. So pull this up. See that? Okay, so kinematics, a branch of applied math dealing solely with descriptions and measurements of motion. Possible, this is from Robert Bennett's paper that he wrote. I don't have or it's in here somewhere. I just don't remember what it's titled, but I'll look it up. Oh, Relativity Paper Analysis and Obituary. There we go. Shout out to Robert Bennett. So kinematics, a branch of applied math dealing solely with the description and measurements of motion, possible real-world motions and abstracted with kinematic variables. So there he goes over the variables here. In abstract modeling of space, the motion of an atomic electron or galactic star would be, would be the same point motion in a circle. All physical properties like mass, etc., and all that are ignored, right? So they come up with their own things to describe the motion that's happening in the system, and then based on that, they try and make predictions and stuff like that. And then we're going to get into the distinction of dynamics. So dynamics, a branch of physics dealing with the predictions of future motion based on Euler and Lagrange equations, the laws of physics, as derived from the Lagrangian variational principle of calculus. Specific real applications and predictions of motion include additional dynamic parameters like mass, momentum, moment of inertia, force, torque, and all that. So all the important factors when you're actually trying to model something. So like, Witsit pointed this out one time, and I thought it was really interesting. I didn't understand like what the distinction would be because it's clearly an odd contradiction, right? So for the mathematics that they use for orbital mechanics and stuff like that, when they're like launching to the moon and whatnot, they use a geocentric coordinate system and all that, and they change the way that the forces that they use, and it's like, why are you using all these crazy, like, that doesn't make any sense. Why do you switch? Well, when you're doing like a real world application and not pretending, you switch to dynamics, and the framework of what how you're calculating changes based on all that. So your starting reference point is going to be stationary, non-rotating. So that's why they use the geocentric coordinate system and all that to plot out how they think going through the gravitational field is going to affect their momentum and direction and motion and all that, right? Like how they're plotting out all that has to be done through dynamics. So that lab frame has to be covariant with all other frames, right? Because everything stems from that. Like you could play around and say like from a reference frame of the sun, blah 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 blah. But like on the for real, we're taking it back to where we can go, which is the stationary non-rotating frame, right? So when lives are on the line, when money matters, when equipment is could be lost or damaged, like you're going with dynamics. So kinematics, the measurement and interpretation of motion by abstract mathematical models used to describe a point motion by kinematic variables. So there was the variables again. So time, initial velocity, final velocity, acceleration, displacement. Kinematic laws include acceleration, path of curve r, speed, all this kind of stuff, different types of relative motion. So, the theory of relativity, is it a big surprise that it's able to make some accurate predictions? Well, when you have the leadway of a coordinate system that conforms to whatever you need it to, well, heck yeah, you can make some cool predictions, but are they dynamically equivalent? Are they meaningful? Are they physically meaningful? That's the $1 million question. So dynamics, the prediction of motion using the Lagrangian method and function of functional variation. So going through all this mathematics stuff that I don't fully understand, they analyze the system and apply like real actual variables to make the predictions of motion, right? All right. So I think
the Lagrange points are like parking spaces, and from what I've heard over the years in the debate about this whole idea is that they're convenient for the explanations mathematically more than anything.
Yeah,
but then this is kind of attributed to being talking about the dynamics, but to make the dynamics work, maybe the Lagrange points were necessary for the mathematics to also work somehow or something, right?
Yeah, that's probably why they gave him the, attributed the name and kept it going or whatever. But yeah, it was yeah. So here is sorry, did you?
I just profit for the question from a new perspective. Hi, Alan. And I have seen your debate with Mike Tom. It was a beautiful debate. So wanted just to say that I stayed not long. I need to go to
Oh, you
sleep.
saw him kick ass last night, huh?
Yeah.
Yeah.
So go on. I finished my point. I wanted just to say hi on GG.
Oh yeah, dude. Thank you, GG, bro.
GG.
Yeah, it was the GG, huh? Yeah.
And
Yeah, that's what's up, man. That was fun. That was fun.
he just fucking crushed him over at Geo's, by the way, too. He was making baller tears.
Oh, did
Dream
you?
away.
I'll have to watch it later.
Yeah.
That's awesome, my man.
Yeah.
Dude, I got a
Right.
backlog of stuff to watch from you, Dave.
Yeah. I'll end up recording the part where he came in today. It was pretty good.
Epic.
Yeah.
That's what's up.
They didn't want to hear it. You got JA saying, "Oh, well, he's just like any of you other religious zealots, just claiming things, you know." When he's got like, like the space agency, it is, like talking about like details and stuff. They were just like nobody piped up, and Zanuck and Kosho left, and then we started talking about planes and interrupt you.
Yeah,
But
you're
the
you're
dynamics
straight.
and the kinematics. Shout out to Michael Brenner, by the way. Yeah.
Yeah, shout out to Michael Brenner. I'm definitely going to have you read some Michael Brenner at the end, so be prepared.
Okay, cool.
Because he's
get
got
queued
some
up.
excellent an excellent take on it. It's really really good. So here we go.
Yeah.
So here is the way the two concepts support the scientific method. Kinematic data analysis of a system establishes a reason for forming a hypothesis. Theoretical predictions are made via the dynamic Euler-Lagrange equations. New kinematic test data either supports or refutes the dynamic theory. Realization that only certain observers or reference frames could be valid or could validly predict motion was probably first documented by Newton in 1687 in the Principia, where the prediction of the spinning bucket observer failed to predict reality, the radial force on the water, but the laws of physics at the time were only Newton's three laws of motion. Later development of calculus and the variations by Euler and Lagrange in 1755 gave an algorithmic prescription that determines the laws of motion by variation of energy function integrals. Very cool. I don't have Twitter, Sacred. Let's see. Okay, yeah. So the role of the reference frame choice has not been the main focus of formal mechanical study. Oh no, hey, you don't say. When basic definitions are not precise or distinct between kinematics and dynamics is ignored or suppressed, then the meaning of an inertial frame to physicists is confused, as it was in the building of the Tower of Babel. So yeah, kind of what I was touching on earlier about the important distinction of a reference frame and a coordinate system. Like they're not interchangeable. They have different implications. And not being specific about these things is what has led to all reference frames are equally valid. Well, which ones? Like dynamic ones or hypothetical kinematic ones where a guy's on the sun and we're looking at an experiment on the earth and we're not seeing contraction. Like what what are we talking about here?
I don't understand how it doesn't just immediately spiral into like meaninglessness. Like if everything's relative, or everything relative is relevant, like I don't. To me, it's just so incoherent. Like, how do you? I don't know. Am I missing something with that? Like,
no. What I think ties it all together is the belief in space. Because without this, you're not moving. You're not. It's like there's no scientific evidence. There's nothing, right? So unless you believe in all this stuff, you can't You can't be on Tatooine. Can't get on a TIE fighter. Like all that stuff is just, a lot comes with not accepting this stuff. Because like we're at like the end result of it, right? Like this is where it leads. So like somebody who isn't willing to take it as far might take it so far as to be like, well, the theories that describe everything, aren't accurate, but like space is still real, But we see what they've done, and they've constructed the entire thing's a fantasy. It's a giant mathematical play.
Yeah.
And all right, so that's all I got. I think. Oh, let me. I think I'll close out on the pruner. So did I cover their last experiment? They got with the two observers matched. They both got a fringe shift pattern corresponding to the rotation of the device, of the part that was rotating, even though there was no reason that that there should be a variance and see if special relativity or if relativity theory at all were true, right? So there's a couple possible interpretations that they go over here. And then what they do at the end is they test the first postulate of special relativity. Are all inertial frames equally valid? So what they do here is they calculate how much fringe should be displaced if the observer was in the traditional location of the Sagnac configuration, instead of on the lab wall or on the rotating device. And what's it called? The classical theory predicts 0.053 in the fringe distance, and relativity theory predicts 0.005 in the fringes. They're 10 times off. It's not like GG, right?
Oh wow.
Yeah, not even close. So the whole claim about like, oh, they're all valid, we can do it from anything, his equations hold true. Nope, sorry, you just got played, player. Now, Paul Lavaux comes in and he's like, hey guys, it's important to remember the importance of choosing the correct coordinate system when describing a system that is in rotation. That's cool, man. That's a valid point, Paul. Let's hear him out. So he says if a device is in rotation, the gravitational effects should pull it towards the center. Thus, the optimal choice to do the calculations should be from the center. Cool story, Paul. That's great. That explains your initial reasoning for choosing that location to calculate from. But can you do it from another location, as you say? No, you can't. And that's the only thing he had to say about this. And he knew about the experimental results. That was his only rebuttal, was to reify the initial claim that to try and say that the only place that would be valid on a rotating device would be the center. But that's just like your opinion, man, to quote the Big Lebowski. All right. So that's Dufour and Prunier absolutely destroying special relativity in 1942 using Aether effects and validating Sagnac's initial hypothesis about the geometry of the ether wind. It is a uniform rotation, and within that, your movement generates its own ether vortex, and that is going to change how you see or how you receive light. That's what they proved. Special relativity says that. What's that?
Stop making sense of all these first order measurements.
Dude, no. No, dude, we have to correct them and fucking contract them.
Exactly.
Yeah, man.
Hey, since Model Builder and I and maybe a couple of our missed the first part of your presentation, I'm not asking for you to go over the whole thing, but maybe summarize or have someone else summarize for a conversation about it. It would help.
No, don't. It is saved on YouTube.
Yeah.
Oh yeah, I could just go back and listen to it, but I thought for conversation's sake we could.
I stay like 20 minutes or so, and I will do my little game, so I will listen to the full things.
Yeah, so will I.
Cool.
So.
I just
Awesome.
thought for conversation's sake, since you want to talk about some of the stuff he said, I'd have a hard time contributing without hearing the first part is all.
Oh no, I got to check pull it up real quick. It's not that much. Because you guys already know like most of the stuff. Yeah, I got you. So yeah, exactly. so these guys reproduced the Sagnac effect of 1913 in its traditional configuration, where all the instruments are placed on the device. They did a secondary configuration where the source of light was fixed to the lab wall, so stationary, to see if if what was causing the effect, if the source of light had any relevance to the effect, right? So they proved that, in this experiment, they showed that all that mattered was the rotation of the device, because the fringe shift corresponded to the rotation of the device at 1 turn per second to the first order And then here's a picture of the comparison of the fringe patterns. So here's the traditional Sagnac setup with the fringe patterns, very cool. And then here's the stationary light source showing the same fringe patterns. And then they did a third configuration where they had a light source in recorders fixed to the wall and one recorder fixed to the rotating frame. And they had a stationary frame here that is connected by 45-degree angled mirrors on both sides. And the light beam hits this, hits the 45s, gets
Hey, real quick, are you
Yeah.
trying to share a screen? Because I don't see a screen. That you're not sharing screen anymore for some reason. For
webcam.
me.
I'm on webcam.
No, it's only you. I think I have the screen. Can you scroll to see if it's updated? Yeah, it works.
Oh, okay. Maybe I have to. It doesn't matter. I'm sorry. I just can't see it for some reason. Maybe it's my internet or something. But
Yeah, it's working for me.
Let's reconnect.
is it okay? Yeah. Sorry. By the way, I just
Yeah.
posted since Model Builder has to leave soon.
Mhm.
He did his own laser test on his table, and he was talking about putting his finger on the table and having it throw it off because it's so sensitive.
Mhm.
Oh, yeah, but anyway,
Nice.
I'll be right back.
Yep.
Yeah,
I'm gonna. Go ahead.
It's totally explained in this experiment. This experiment blow my mind every time. It's like beautiful idea he has to change the frame of reference. So,
Oh, the Dufour and Prunier.
no, the frame of reference. You change the frame of reference of the light by putting the light outside of the experiment. I get it right.
Yeah.
Okay.
Yeah. That's Dufour and Pruner that did this. That's what we're talking about. All right, Dave. I took some screenshots so you can kind of see the configuration of the apparatus since you can't see the video or whatever.
No, I can see it now.
Oh, okay,
No,
cool.
I'm there. I'm there.
Oh,
Yeah,
okay.
I just had to rejoin.
Oh, gotcha. Okay. Yeah. So that's it.
So this is a totally new thing that you just discovered. That's just, what did it say? Foreign pruner.
Yep, the Foreign
What's his
Pruner
name?
from 1942.
The foreign pruner.
Yeah, I didn't discover it. It's been like where did I hear about it at?
Well,
I can't even remember. Oh, I think it was from James Demio's site where he has the whole list of ether experiments, and I just started looking over it, and then that's how I found Robert Bennett, who has a review of it. So this paper, in conjunction with the Dufour and Pruner, really helped me understand it because I must have read the Dufour and Pruner paper like 17 times before it started making sense. And then I was reading Robert's paper here, and I was like, where is he getting all this from? Like, what does this mean? And then, and I just had to keep going back and to get it. But yeah, the breakdown is awesome here. Like all the stuff that I was talking about, the kinematic relationship, the how each experiment specifically invalidates relativity theory, all that stuff that was broken down in here from him. Really cool stuff. Highly recommend reading that. And for those who don't know who Robert Bennett is, he is a PhD physicist. He taught physics for like 30 years, at a high level. Like his thesis that he got his PhD on was on gravitational effects of rigid bodies. Like, this was a relativity guy, through and through. And then, he just realized, that was all BS, had that waking up moment and started. What's that?
And he's going to be on with Witsit, you said, right? Coming up.
Yeah. We have it planned to do it in the field episode where he's going to do a 2-part presentation.
Sweet. Now he hasn't come out publicly at all before. Like that's going to be his coming out to the public.
Oh no! No! He's not a flat earther or anything. He's a geocentrist. But he co-wrote the book with Robert Sungenis.
Oh, okay.
Yeah. He's contributed a ton of work to geocentrism. Like a lot of his papers that he's posted since his retirement are just absolutely annihilating the motion of Earth. Like it's dude. Yeah.
Could you just for me explain geocentrist? Is he believe on a globe, but a stationary globe?
I think so. Yeah.
Yeah. However, that's possible.
Yeah, because I have a hard time with map and so on. Because I know for a fact we're stationary. The observation tend to a flat Earth, but if if we are not on the globe, that imply there is a huge hiding things in the cartography.
Right.
You understand what I mean?
No, absolutely.
So,
Absolutely. And I don't think that he's ever even like familiarized himself with that stuff because he's an older gentleman too. And, he's retired. So I don't think he's like necessarily even like looking into flat earth and all that stuff. So
Oh,
I think,
funny. Isn't it weird
yeah,
the degrees that people allow themselves to go to without thinking that like it's also level? Like I've been trying for years now. I've been trying to think of the perfect question
I
to
agree.
ask a geocentrist or a concave earther that that just shows them that no, there's no upside down people. Okay, can we just get over this idea, please?
yeah. Well, again, what I think ties it together though, and I'm not speaking this to Robert's perspective. This is just what I'm conceptualizing in my head. Is that I think that the reason that they keep the globe and all that is like to kind of still have the idea. They're like, oh well, yeah, there's satellites and people went to the moon and like, yeah, there's space travel, but it's just going to be closer, maybe. You know what I mean? Like it's like because think about what it would mean to like to go to not only say Einstein's wrong, but to then turn around and say that like NASA's not going anywhere. You know what I mean? Like you gotta like that's a whole nother level of commitment to
Yeah, if you've missed some of those steps along the way, yeah.
Especially
yeah,
if you have a name for
Learn,
yourself.
so.
right,
It's like,
right.
and you don't want to be dishonest intellectually with yourself. So you have to convince yourself that you can go so far, but then there's like it's like they almost know that they're going to be losing credit with the mainstream or whoever the people that might approve or disapprove of what they're saying. So they don't allow themselves to think it because they know how they're going to be judged if they do.
Yep.
Yeah, that sounds like an accurate
No,
take to me.
that's absolutely it, man. And then I got some anecdotal info to drop too. So Bennett actually reached out to Ruyong Wang of the 2004 experiment where he linearized the Sagnac effect and asked him if he was interested in like pursuing more tests that would falsify relativity theory. And Wang declined the offer. And the way that Wang was speaking to Bennett, he was saying that he was like, yeah, it was clear that he was intimidated and like he didn't want to pursue it because he would like lose his career.
Wow.
So
Yep.
crazy because
Makes sense.
because a lot of I've read a bunch of Wang's papers and like there's like at least 3 or 4 of them are like, hey, there's a huge discrepancy here with relativity theory. Does anyone want to do these tests and like pursue this? And I guess they got a talking to, because he never pursued them. And then when asked if he was interested in pursuing them, he declined.
Well, that makes at least he's acknowledging that he knows he'll lose his career if he even says it. But the other guys may be unconsciously not even allowing themselves to think it, like like we were just talking about. Like that's
Mhm.
maybe at least you have to give him credit there
Yeah,
for knowing that this is a career-ending type thing.
yeah, absolutely.
Huge.
What up,
Can't wait for that.
JT?
What's it
Oh
say?
yeah.
When do you have any kind of time frame? Is it going to be coming up soon, or you don't
No,
know?
I sent Whitson a message the other day. I'm just waiting to hear back from him to get it scheduled. Bennett's got the presentation already set up. I looked through the slides. He had 68 when I last looked at him. We're gonna break it into at slide 30. We're gonna stop, take a break, and then do the second half at a later date. Um, but yeah, dude, it looks, dude, like heliocentrism will never be the same after this. Like I'll say that.
Yeah, that sounds awesome.
Because this dude, he's so precise with his language and like the definitions. Like you can't like all this like dynamics and kinematics and what it's a reference frame and a coordinate system. Like when you start actually defining this stuff and you like when you hear it out, it's gonna be insane. Like it's never gonna be the same again for the relativist dude. It's gonna up our game to an insane degree.
How are we,
Now, when
how,
you
how are we going to spin him up to have a little chat with McToon to start debating for us?
Oh, he's
well, he's not going to debate for us because he's a geocentrist. He's not a flat
Yeah.
earther. But it'd be interesting to look at his slides, or maybe even ask if you have yet, to figure out how they convince themselves that there's still people upside down, or that the planets are going below us.
like
And the
like
stars
I
are
just
going
told
below
you,
us.
like I'm sure he's like has extrapolated some gravitational effects in that cause something, right? So I'm sure that that's the like because that's the easy way out, right? Like you don't have to It just makes sense. It's the path of least resistance, in my opinion. So that's what I would do,
Yeah.
right? So
Well, Witsit talked about this when he was going to have Robertson Genis on, and how he was going to, like maybe subtly mention it, or maybe at some point even talk to him on that level. And it'd just be interesting to figure out exactly how it is. I mean, it is the path of least resistance as far as what we've been given for the model, but then maybe like that, of course, the next step is then to show them at some point, or yourself at some point, how it is that they're able to take this, and the gravitational effect is not necessary for it to work in the way that they think, or whatever. So
Did you
figure it
hear
out.
Witsit's talk with Robertson Genis already that he had in the field?
Oh,
dude,
that's great.
it was awesome.
And then at the very end, he's like, okay, next time let's go like debate format, or let's go a little harder, because it was real gentle and they were just talking about what they agree on. And he was just really respectful of him and thankful that he did the
Yeah.
principle. And I can't wait for him to have a little deeper talk.
It was so crazy how much Robertson Genis knew about like the reverse engineering and all of the discrepancies and the oversights, intentional oversights, and like he's like fully there, but he doesn't get the next thing, which is like, no, it's not even a ball, bro. It's not even a ball.
Yeah, it's like it's that component that a lot of people don't want to talk about, the spiritual component about being blind or having a veil over your eyes. It's truly a blessing if you can see clearly the truth, or at least get closer to the truth than some. Because the biggest thing that I've thought about lately is, if a person truly thinks that they already have the truth, they view us as we're deceived, we're goofy, we're dumb, we're silly, we're retarded or whatever. But it's a humble thing to set everything aside and investigate what's presented, both globe and flat, and then you can actually start finding the truth when you come into it with kind of a clean slate.
Yep. Yeah, and it's crazy how it can be so well thought about just as a geocentric model. Like, obviously it works, and that's the thing. If we're talking about the dynamics now, and how he's showing that the dynamics work with the geocentrism, and that's what bugs me, is that like the dynamics have to work over a flat Earth too. And what is it about the dynamics that would have to change if that were the case, as far as what the results they're getting? That's what
I think
I would be
maybe just
interested in figuring out.
I don't
maybe
think
some people are just not curious. It's like they just see the hole and they're just like, all right, I'm not gonna look in it, but I see a hole.
But they've looked at all the other holes. Like, that's the thing. Like the interview with Robert St. John's, he's like, he sees all the holes. Like he gets how they
It happened
totally
to me.
finagled things.
there are certain things that they aren't willing to acknowledge, right? So
Yeah.
like Sangenis has debated flat earthers before, like he's aware of it, like he's not ignorant to it, right? So he's obviously seen he's seen like things like the black swan, and like a lot of all that, like all that like basic kind of stuff, right? That we've all seen. And then when what's his name, when Pitch Lumen was asking him about that in a debate, he acted like he had never heard of it and that kind of stuff. And it's like I've seen that done with some other with another academic guy that I know, where I've shown him some observations that defeat 8 inches per mile square, and the guy's just just no acknowledgement of it, and then like weeks later he'll be on stream and I'll catch him talking for a minute and he'll be like, yeah, I just don't know what's up with these crazy science deniers. It's like, dude, dude, but people are just going to do what they do. Like when they hit that threshold limit, like it's GG,
Yeah.
like we probably all have threshold limits on stuff too,
Yeah. Well, I guess so. Yeah, that's true. We all have our limits of what we'd rather not know. Almost.
I think just the social ramifications of it is just like, oh man, I'm gonna be one of them.
Yep. Yeah, man. Nobody wants to be the guy.
Absolutely.
The Ash conformity experiment proves that in situations where the stakes are nil, right? where where the stakes are some people you don't know might think you're dumb, you know?
Well,
Like
for
that,
sure, I was like
like
frustrated
yeah.
as I was looking into it. I was like, "Are you serious? Am I seriously gonna end up being a flat earther?"
Yeah, dude, like yeah, when kicking, dude. If you don't go kicking and screaming, there's something like not right, you know?
Right, right.
Because I went through the same thing. I'm like, come on, man, are you for real? No space. I'm like the moon landing. They didn't go. They just pretended. It's not even not
Oh,
one,
I
not
was way
one moon,
past that
not
point.
one moon rock. Like yeah, like well, that was like my early
I
journey.
was like specifically afraid of the title. I didn't want it. I didn't want to be it. You know, it's like, oh man,
Yeah,
it's
No
seriously
friends
gonna be
and
one of those.
yeah,
I don't want friends and family.
yeah.
And
But yeah,
once it
you
said
know,
it, like
it's the
it's
truth.
you're gonna if we go from like if we go to geocentrism first, that's he thinks that's a ticket for the ballers, because they'll go geocentric at least to start with.
It's a
But
gateway
it's just
drug.
like ultra frustrating. So
Yeah,
yeah, it's frustrating because there was a troll back in the day that was like the major I don't know troll of the flat Earth at the time. There was like one or three or four of them, but yeah, it was what's his name Tim Osman, and he was like in the debate with him even when I was talking to him, he's like, I'm okay with it being stationary, but it's definitely a ball, like even he was there at that time, like,
mm.
and it's just like no, it's not a ball, okay, just get the
It's not
ball.
a
Can we just
stationary ball,
you
guy. Yeah, no, I feel that,
why
but
it doesn't
yeah,
work.
yeah. But sometimes you need it to work for social acceptance, right?
What do you understand why? I mean, if we're talking about the dynamics, not that you have to go into all that, but like, how would it be a ball stationary with everything? Because then it would have to be like the attractive force would have to be huge for everything to be revolving around the Earth. Like, is that a nodal point in space that they've got some kind of like theory behind that makes sense in that way, or is it just
I
modeled
think they
out
would
so it
just
makes
take
sense?
their conception of gravity and apply it to a local flat area projected in a station, in a geocentric coordinate system where space isn't moving or anything, right?
And the force is strong enough. I mean, wouldn't you think it would be a stronger force if that was the case?
Well, if you don't
Because
have to,
it would be the center.
if you don't have to actually verify it, right? You could mathematically extrapolate what forces would be required, and then say that you're accounting for these things, physically, and then just not, right?
Okay, so they're having to finagle it almost themselves to make it work.
Well, yeah, like mathematically, it's gonna look solid, right? They're gonna be like, oh yeah, dog, like this is how we put people on the in the direction that they need to go when they're going into orbits, right? But then they don't actually go into orbit, right? But mathematically,
Well, that's the whole point, though. Is that the dynamics would show it. You would think if they're showing the dynamics, then that would actually
right? But
expose the math, which is what it's
well,
supposed to do.
no, they have the dynamic math, but they don't have to prove it because the spaceship or the rocket when it just goes out of scene, it just they say it's going over the curve or whatever, you know, but it just goes out
Okay.
into space. So like they've got the math, they just don't have to back it up. You know what I'm saying? Because that would be the falsification of their fake dynamics, right?
You,
Realizing that the
you know
rocket
what?
doesn't go anywhere.
It's something that blown my mind even when I was a global. Is like they was able to send some satellite near the sun, but they missed the distance of the sun at some point. Like they changed the distance of sun, but every other computation is right.
Oh yeah, when they were gonna when they were gonna adjust it, where it would have literally affected everything because it's all based off of that.
Yeah, yeah, that's my point. Yeah,
Yeah,
and
yeah,
they use satellite with wrong wrong data, and
yeah,
it worked.
yep. Yeah, have you ever heard of the what's it called? The Voyager 1 and Voyager 2. I forget which Voyager's out there, but whichever one's the furthest, right? Apparently it's so far out there, right, that it passed this thing called the magnetosphere or something, some giant so-called plasma wall, blah blah blah, right? So it's way out there, right? And it sends a signal back with less energy than it takes to turn on a light bulb in your refrigerator by like an insane order of magnitude, like of orders, right?
Yeah.
And then what's that?
Yeah, go ahead.
Yeah, so they send this data signal back, right? And it takes like, I forget, like three hours or some shit, based on the speed of light and a distance of 18 quad billion or something, right? So they get this signal back, right? What including the inverse square law, attenuation of light, anything like as this little fragment of signal propagation is going through this vacuum or whatever, and then it hits this magnetosphere, plasma shield, and all this stuff, and then it hits us, and then dude,
need Earth to
dude,
do this transmission.
what's that?
They would need Earth. Have you heard about Earth?
What's that?
HAAFP.
HAAFP?
No, AFT. AFT, aft, right?
P comme P like Paul.
AFP.
Paul.
Okay.
Yeah.
What is it?
It's a huge platform, radio platform that consume a huge power to do some tests on the magnetosphere of Earth. And they would need use something like that to be able to transmit signal at those distance.
Oh, I'm sorry. It wasn't the magnetosphere of the Earth. It was this other thing that they say that we're encased in. That's from the
yeah, it's
from the sun.
You speak about I don't recall the name.
Yeah. It's something, right? But anyway, the point being though is that this like little tiny insignificant propagation, they pick this signal up somehow and get this data from a like, it's insane.
I don't know about I don't know how to pronounce this in English. I will try to find some link for you. High frequency auroral active auroral research program.
No, never heard of it. Is that where they have the giant antenna array to get the signal?
Yeah, exactly.
Because so that's how they say they get the signal, that they made a big catcher's mitt basically, and it's
but I have done some radio work. I am not an expert in radio, but I used to. I am an embed developed engineer, so I have done some radio software and so on. And like with tiny signal, we can reach without a competitive antenna. We can reach like maybe 100 kilometers. So it's the farthest you can get with a good reception system. I mean, it's exponential. The power needed to catch that, it's exponential. The problem is
that's what I thought, because the way that they try and make it sound is like, well, we backloaded the capabilities on our end on Earth where we could make where we could compensate for that, but it's like the signal they're sending so weak. How could you reduce the noise, right?
You cannot differentiate your signal from the noise. It's impossible. You need to have the power, the source power to be huge.
Yeah, it would have to be proportional to an exact exact specificity. Yep. That's what I thought.
You cannot rely on the reception system from that type of get. You could never say, "Oh, it's my signal." I assure you, it's my signal. It's not an error. It's my signal. You know?
Yeah. Cool.
The noise would be like 10 to the power, I don't know, more powerful than the signal. The noise itself.
The background noise would be larger than the signal. Yeah, no, absolutely. Dude, by an insane order of magnitude, bro.
Exactly.
Yeah, it's crazy. It's crazy. Because you know where they screw themselves is they always try to brag about this stuff, and they're like think of a refrigerator light, and then think of like what it would take 1,000,000 times less power than that. That's what we send the signal with, and it's like, oh really? Oh, tell me more about your refrigerator light.
I used like to do a transmission at about maybe 2 kilometers max, maybe 3, 4 on a very good line of sight. I used, if I recall correctly, like 10 milliamps, and I was like with very low power radio. And 10 milliamps is like, yeah, 5 times less than the LED system in a fridge, you know.
Crazy, dude.
So the number is not speaking to everybody. I know I will not explain the proportion, but it's like you have the little battery of a watch, of a toy watch, and you use that to send the signal from to Earth from like 3 hours of light years. 3 hours light ago. Like you used just a little battery from watch from I will find a pic
Cool.
like that. Yeah.
Let's see what we got here. Oops.
You used less than the power of from those battery.
Nice. Shout out to the Swiss. Those guys make really nice batteries. I heard.
Yeah, so they said you used less than that to do the signal transmission. Is what they said.
Crazy.
And this is a phased array antenna. This is a evenly precise directed antenna. They can send signal very, very precisely. It used every antenna is like the dot of a screen pixel. It works exactly the same.
Okay.
We don't are you new perspective?
I'm sorry, what'd you say?
Ah, you are not speaking. Okay.
Oh, am I muted?
Yeah, I have seen you like speaking, but
Oh, I'm sorry. Maybe I was hot micing. Sorry.
yeah, it's mind blowing. Like how they could do that. Like um, it's not even. Yeah, I mean the person who works on the satellite. You just say okay, don't worry, we have the reception system. You know. And people are like, oh, okay, I don't care, I don't take a look. I trust the fact the reception system will be able to take from noise and so on.
Yeah. That's how they get them, dog. That's how they get them. They're like, we just built a big catcher's mitt, and everyone's like, cool, I like catcher's mitts. You know?
Yeah. It was great actually. Over at Geo's just now with I asked Labette if he could just explain a little bit about working at the space agency and how it was that they were compartmentalized enough to keep him believing that the satellites were giving him the data and all that. And he was going into a whole explanation that I think probably triggered a bunch of people because he was like, you could be like right there, and he was like so well hit, like there was 3 doors you had to get through sometimes to go with certain sections, and you were just like giving data to one person, you have no idea what they're
Yeah.
doing with it. And yeah.
I have used the metaphor of the black box. So it's like when
Yeah.
you cannot work on the company without signing some confidentiality things, the first things. And when you work, you have just input data, output data, and you connect to a black box. Someone has done. and you only know how to put the data in it and how to output the data, and you don't know how it's done. So it's only a bunch of black box put together, and I was confronted to the fact that I would debug some software without even having the true data, only false data. Because it's so heavily compartmentalized that I could not even test my software on the true data.
Yeah. It's locked tight.
Crazy, man.
Sorry,
Perfectly designed to keep people believing it without knowing what the next person's doing. So that they
No, but
very
like,
well
no, but like,
structured.
don't you know that GPS proves we live on a globe?
yeah, man.
Like,
What
can't you
what I
just?
was saying is like I can be sure every the companies that have done the so-called GPS satellites, toward one dozen satellites, they at some point they know, because it's army and so on. At some point, at some level, they know the true shape of Earth, but every company, ST Microelectronics, Texas Instruments, who have done the GPS receiver systems, I am sure every teams that have worked on it believe we are on a globe. I am sure.
Yeah.
They believe we are on a globe because they are giving someone somewhere give some black box and said, okay, here's some matrix, here's some input data, and you have your output data. And what you are doing is only a radio receiver system that gets the data and output something. So, like, no, everyone is not in it, and you don't need to. You just only need to control every part of your team system. It's just you have to do, and you get only the data need to build something for the team occurring. So one team is doing some vectorization software, other team is doing some I don't know some reception system. The other team is doing some black box to some box to put it in a satellite. The other team is doing the emission system with the parameters given. So if you tell, you can you have an energy problem, or you could totally be low power, don't worry. Oh, how they could imagine the satellite will not be in space.
So let me ask you a question, Labat. If you have some working knowledge of GPS, doesn't GPS use a ECEF coordinate system, meaning a Earth-centered, Earth-fixed coordinate system, as it's like
you really need to check that, but because clearly it's a XYZ system. It's clearly a XYZ system, so it's a Euclidean geometry system, but it plots you on a globe on the XYZ system. And I don't recall, because it's a long time, I don't recall the Earth moving in the system. So yes, it's an ECU system in my memory. But I don't want to make the claim because I don't have the data sheet on so on. But
I got you, bro.
if I remember correctly, it's a XYZ system on Earth reference system, so not moving.
Yeah, well, the ECEF is the XYZ coordinate system, and so it's a Cartesian coordinate system where the x-axis passes through the equator and prime meridian intersection. The z passes through the North Pole, and the y is orthogonal to the x and z. And so basically, your meeting point is at the center of the Earth.
Yeah, it's exactly that. What I recall is exactly that. Yeah. So I did not see the screen. It's okay. There we go.
Yeah, you're good. Napalm, to answer or to add add on to that. So I put 3 PDFs in there. Those are the what do they call them? Whatever the interface something documents for GPS, like how they work and all that, how it takes its measurements. So it uses a range measurement equation, then obviously in the ECI reference frame first, right? So they take a stationary non-rotating reference frame. So the important distinction with this reference frame is that it is stationary with respect to rotating stars, and then they take that distance that they derive in that first frame and they transform it to the ECEI, the ECIE frame. That's not even that. The ECEF frame, the Earth-centered Earth fixed frame, which is a rotating frame with respect to fixed stars. So that's the distinction that they make there, for that, if that helps. They start with a fixed position.
Gotcha. And then the ECF rotating.
Yeah, the
frame. Okay.
ECF is what they say is the one that we live on. They say that's the GW8 ellipsoid or whatever, right? Or the G86, whatever they call it. That's what they say.
WGS 84.
Yeah, and then they say that the Earth-centered frame is like the hypothetical frame that's not real, but it's the inverse, right?
So they transform it from the Earth-centered to the Earth. So they transform from the Earth-centered Earth fixed.
So they take their when you get your GPS signal, that first measurement that it's taking it in the ECI reference frame, and meaning stationary fixed reference frame. So it's interpreting everything as stationary and not moving with respect to the with respect to rotating stars. So as if like the background's rotating, but not us.
Gotcha.
Yeah, I can back up. It's what I remember. As we spoke about the first time we met. So. But I clearly remember that. But I don't. I have worked only with GPS receiver, and I worked only on my data, and it confirms the like I listen to too much globals. Oh, there is engineer working with GPS. Yeah, I am on. So yeah,
So
like
the first.
I just get my latitude, longitude, and do my stuff. That's a matter of the fact. I did not work in the module GPS receiver. I worked with the GPS receiver and connect to it, asking from satellite, asking from. Oh yeah, I get 4 satellite. I have a strong signal. It's just a black box. It's just a little black box, and I connect to it. And it works every time like that. I don't know if it was clear, but
Yeah, we got you. Yep, the black box concept's great. Yep,
yeah,
like
it's
Schrodinger's cat.
there is not too much people that have worked into the GPS. Like okay, some people have having some module receiver module and getting some data. Yeah, there is a lot of people, but I am one too.
I'm sorting that's why I'm posting these things in chat, by the way. I've posted the actual burner comps that I'm reading from, and then I'm sorting out some clips that I wanted to read just a little bit of each from whenever that time comes
sweet.
around.
Perfect. Yeah, I was actually just gonna say something about that.
Cool. Yeah, I'm working on it right now.
Cool. Yeah, whenever you're ready.
It was a pleasure. Thanks for
Awesome work today, man. You did great. That was really funny, fun. Really great. Really, yeah, I'll definitely record that and post it for everyone else to hear too.
Yeah, it was fun because I know that there was 3 globals and.
All right, boys. Shout out to the level heads who have showed up in the chat. I see you guys out there putting up for the squad. Hashtag level heads with a Z. That's what's up. Yeah, I'll definitely hit you guys up on Twitter. I'll make one after the stream. I'm about to wrap up here, close out for the night. and chill out for a little bit. But yeah, I'll hit you guys up. All right, so thanks for coming out. Thanks for coming out to the stream. Hope everyone enjoyed. Hope everyone learned something. And see you guys next time. I might have something coming up on Saturday. Might be doing something with my buddy I Can Science That, where we go into a little more specificity, kind of reviewing the debate with McToon, and kind of clarifying on some points that he thought was interesting and wanted to know more about. So we'll probably set that up for Saturday. Not sure at the time, but it'll probably be late Eastern. He's a Pacific lad, so it'll probably be at least 1 a.m. Eastern. Before we go live, it's usually when we do it. So, all right. See you guys on the next one. Have a good night.